Good morning students. In this video session, I am going to explain about one of the important illustrative example, that is binary search. The previous video session I explained about the linear search. Okay, it's just different from the linear search. Linear search, we are searching the element linearly or sequentially. The binary search, we are dividing the list into two, and one portion only we will going to check. That the reason it is named as binary search. The whole list is divided into two, binary. And the other name of binary search is half interval search or binary chop. Okay. Before going the program, I will explain the logic first. Okay. There are few steps you have to follow for doing the binary search. First, ascending order. Always you are given input, the list input should be in ascending order. Otherwise, you can't able to perform binary search. The list should be in ascending order. Second, you have to know how to find the mid value. Okay, as you want to break the list into two, binary, you want to find the mid. So, for finding the mid, we have to know the first and last. Always the first index is considered as the first and the last index is considered as the last. For calculating the mid, first plus last, floor division by 2, floor division. It will give the quotient but without pointed values. For example, 4.6 means it will take 4. All of you got it? 4.9 means also it will take 4. That's the floor division. Okay, this double slash 2. Then then you have to check three conditions for doing the binary search logic. The first condition is the list of mid. After finding the mid, list of mid less than search element and list of mid greater than the search element and the list of mid equal to search element. What are the three conditions? Mid is greater than yes, mid is less than yes, mid is equal to yes. So if the mid is less than yes, list of mid is less than the search element, you have to increment the first. If the mid is greater than the search element, you have to decrement the last. If it is equal to search element, you have to increase the counter value. Okay, now I am going to explain with one example, then we can see the program. Okay, so see this example. What's the first rule? Whether the elements are in the ascending order. Okay, here 10, 20, 30, all these elements are in the ascending order only. Okay, what's the second rule? You have to find the mid. How to find the mid? For calculating the mid, you have to know the first and last. The first index is considered as the mid equal to first plus last floor division 2. The first index is considered as the first and the last index is considered as the last. What's the mid now? 3. So this 40 is considered as mid. This is the mid. After finding the mid, you have to check three conditions, right? What's the first condition? If list of mid less than yes. Okay, so what is list of mid? 40. What is search element? Search element is not fixed. Okay, so select the search element. I am going to select 50. My search element is 50. As it is a binary search, I need a search element, right? I want to search one element. So your search element is 50. So list of mid less than 50. Condition true or false? Condition is true. 40 is less than 50. Condition is true. If this condition is true, what we have to do? You have to increment the mid. First equal to mid plus 1. So now what will happen? Your first will be incremented as mid plus 1. Already mid is 3. 3 plus 1. So your first is now 4. What's the first value? 4. So 50, 60, 70. Now your 50 is first and this is last. Okay. So what's the index here? 4, 5, 6. Again you have to calculate mid. Okay. So for calculating mid, what's the formula? 4 plus 6 divided by floor division 2. So 10 divided by 2, your answer is 5. So now what is the mid? This is the mid. So again you have to check the three conditions. The first condition is if list of mid less than 50. What is mid now? 60. 60 less than 50. Condition true or not? Condition is false. If condition is false, it will check the next condition. List of mid greater than yes. List of mid is greater than yes. What is mid value now? 60. 60 greater than 50. Condition is true or false? Condition is true. So if the condition is true means what's our logic? Last equal to mid minus 1. Last equal to mid minus 1. Now what will happen? What is mid already? 5. 5 minus 1, 4. Now last equal to 4. So you will get the list like this. 50. Okay. What is first? First is 50. What is last? Last is also 50. So 4 plus 4 divided by, this index is 4, right? 4 plus 4, 8 by 2. Now your mid is also 4. So first is mid, last is also 4 and mid is also 4. Again you have to check the condition. Now what's the mid value? List of mid is 50. Greater than 50. Condition false. Less than 50. Again condition false. Equal to 50. Condition is true. At that time you have to increment the count. These are the 4 logics. Here I am going to explain. All of you got it? So here in this program I am getting the input dynamically, getting the list dynamically. For getting the list dynamically, first what's the step? What's the first step? You have to create the empty list. So I created the empty list. Okay. I am created the empty list. Then that is this. First I am just printing the heading binary search. Then I am going to use the counter. So I initialize the count equal to 0. Then I am going to get the list in runtime or dynamically. So I am creating the empty list. What's the list name? List 1. Okay. What's the next step? I want to fix how many element is present in the list. For that n number of elements. Find for how many number of elements I want to get as input. For that only this n equal to int input of enter the number of elements. So in the output screen it will ask enter number of elements. For my example I am giving 7. Okay. What's the next step? It will just print enter the elements one by one. Enter elements whatever present in the printf statement, double quotes, it will be printed in output, right? So enter elements one by one. Now I can't able to give all the 7 elements at a time. I can able to give the input only one at a time. So I want to perform 7 times. I want to get the input for 7 times repeatedly. The same process I am repeatedly doing. So what will happen? What do you want to do? I want to use the loop. So I am going to use the for loop. Okay. So for I in range of 0 comma n. What's the n value? N value is 7. So it will generate the number 0, 1, 2, 3, 4, 5, then 6. N minus 1. As it is started from 0, n minus 1. So each iteration, the I value, take one value from here. So at first, what's the I value? 0. That means for the 0th index, you are going to get the input. How to get the input? Int input of function is used to get the input. If it is integer means int input of. So I am declaring one variable a equal to int input of. For example, here my input is 10. Now I want to add this 10 inside the list. So for that, one predefined function is there, append. Where I want to add it? In the list 1. So list 1 dot append. Append means add the element at the end of the list of a. What's the value of a here? 10. So in the list 1, add the element 10. Which position? 0th position. Why? Your index value, I value is 0. The next iteration, what's the I value? 1. So I am getting the second input, 20. It will be appended. Then in the next iteration, I value equal to 2. I am getting the input, another input 30, appended. Like that, 40, 50, 60 and 70. Like that, the elements are appended one by one till the range values are over. Once the I value is 7, it will come out. What is this line? List 1 dot sort. The first rule, always the input should be in the ascending order. Suppose your input is not in the ascending order, means I am using another predefined function sort. What it will sort? The sort function will sort the elements in ascending order. Which elements? The list 1 elements. That what? List 1 dot sort. So all the list 1 element should be sorted into ascending to descending. Okay. Then for binary search or linear search, which one is required? Search element is required. So I am getting the search element. Search equal to int input of enter the element to search. So it is also displayed in the output screen, right? Here 10, 20, 30, 40, 50, 60, 70. Then enter the element to search. Enter the element to be searched. My search element is 50. Okay, I am taking the search element is 50. Now for solving the binary search, we need first and last element, right? So I am initializing first equal to 0. I am initializing the first position, this 0 position as 0. The last equal to number of elements minus 1. Why number of elements minus 1? Actually, your n value is 7. 7 minus 1 is 6. As it is started from 0, we have to put till 6. That's the reason last equal to n minus 1. That is 7 minus 1, 6. N value equal to 6. Okay. Now, see the while loop. I want to repeatedly check 3 conditions. What are the conditions? List of mid less than yes, list of mid greater than yes, list of mid equal to yes. I want to repeatedly do till the last index. So I am using a loop here. So the while loop condition is first less than equal to last. The condition will be this first can reach this last. If it is beyond the last, it will come out of the loop. What's the condition? The first element can go till the last. First less than equal to last. Then another condition is always the count equal to 0 and. So both the condition want to be true. If the count is 1 means the loop, it will come out of the loop. These are the 2 conditions. First will go till the last, then count is always 0. Here, what's the next step? You have to find the mid. Mid equal to first plus last divided by 2. What is first now? 0. What is last now? 6. So 6 divided by 2, you will get the 3. So what is mid value now? 3. Now list of mid. What is list of mid? So in the list of mid, 3, this is the mid. So in the list, which element is mid? 40. So 40 less than search element is 50. Whether the condition is true? Yes, the condition is true. If the condition is true means first equal to mid plus 1. So I want to make this first as here. Now which one is the first? Which one is the first? Mid plus 1. So already 3. Now 4 is the mid. Now 4 is the mid. After completed this, it will go again here, right? Okay, again mid plus, so first equal to mid plus 1. So first equal to 4 now, last equal to 6. Okay, so again I want to calculate, right? So first less than equal to last, condition true. Count equal to 0, condition true. Calculate the mid again. So 4 plus 6 divided by 2. So 10 divided by 2, you will get the 5. Now which one is mid? First is 50. Then this is mid and 70 is last. 50 is the mid. What's the index? 4, 5, 6. Okay. So again you have to check the condition. List of mid. What is mid now? 60. 60 less than 50. Condition false. It should not be executed. Else if the first condition is false, it will come to the else if. So here list of mid greater than yes. What is mid now? 60. 60 greater than 50. Condition is true. If condition is true means what we have to do? Last equal to mid minus 1. What is mid now? 5. 5 minus 1 means last equal to now 4. First is also 4. So again check the condition. First less than equal to last. First is 4. And less than equal to 4. Condition is true. And count is also 0. So again calculate the mid. 4 plus 4 divided by 2. So 8 divided by 2 you will get the 4. Now mid is also 4. Now what will happen? We'll get the value like this. First, last, mid. Everything represents 50. Again, while loop will be, now you are solving the while loop, right? So, again this, then mid will be calculated. Now again, list of mid. What is mid now? 50. 50 less than 50. Condition false. Again here, 50 greater than 50. Condition false. So if both the thing is false means what will happen? It will come to the else. Else means here equal to yes. Instead of putting the condition, I directly put else. So you have to increment count equal to 1. Now after checking this, it will go to the while loop. Now first and last is 4. What is count? Count value is 1. Here AND operator, so condition is false. So once the while condition false, it will come out of the while loop and this if statement will be executed. If count equal to 1, element found. Actually now our count equal to 1. So you will get the answer element found. Element found. If the first element is greater than the last means it will show element not found. The count is not incremented as 1, it will print element is not found. Okay, what are the things we discussed? First, get the list in the runtime, then search element, then define the first and the last, find the mid, then 3 condition. List of mid less than yes, list of mid greater than yes, list of meat equal to yes. Okay. I hope you understand this binary search concept. Thank you, students.